What's up, mathletes? This is section 1.3, solving linear equations with your boy, Mr. Bergman. Here we are. What is a linear equation? Well, let's get right to it. Linear equations don't have any exponents, or no written exponents at least. So there's no x squared and there's no y squared and no x to the third. It's just the highest exponent is 1. And when you graph it, then what you get is anytime you graph a linear equation, you get a straight line. The way we're going to solve linear equations is through SADMAP. First, you're going to undo subtraction and addition, and then you undo multiplication and division, and then you undo an exponent, and then you do a parentheses. This works really well if there's only one x, if there's only one, if you only see one variable in one instance in the entire equation, as you'll see in plenty of these. But if there's not, then you can always add or subtract a term from both sides. If there's variables on both sides, then we know how to take care of that. And if you don't, I'll show you. Okay, so for example, we've got this, it's easiest to report your answer like this, like an improper fraction, like 5 over 4. If you get an answer like 5 over 4 or 10 over 3 or 9 over 15, 9 over 16, something like that, then report those. You don't need to change it into a mixed number or a decimal. So let's get right to it. I see addition and multiplication. I'm going to undo the addition first by subtracting 8 from both sides. And then I undo the multiplication by dividing both sides by 4. And you get your answer of 3. Word problems. A waiter earns wages of $30 and gets an additional 15% in tips on a customer's food bill. The waiter earns $105. What is the total for the customer's food bill? So basically this waiter gets their money two different ways, through tips and through just their actual salary, like what their employer pays them. So at the end of the day, they brought home $105. How much, what was the total for the customer's food bill? We're going to do guess. We're going to do GUESS. We're not going to guess the answer. It's not guess and check. It's just how we're going to organize the givens first. The givens are you get paid $30 one time, just once, and then you also earn 15%. And then the total earnings are $105. What is unknown? It doesn't say, it doesn't specify a letter here, so it's really important for us to take a moment and actually choose a letter from the alphabet. Again, it's the easiest step, and it's the step that students also forget to do the most. So don't forget, what is the total for the customer's food bill? We need a letter from the alphabet. I'm just going to choose the letter B for bill. So, and it's impossible. The reason why it's so important is because it's impossible to do the next step if you haven't chosen a letter from the alphabet. Because then now we got to write an equation. Equation is whatever he earns comes from two different funding sources, the wages and the tips. And so to start solving this, we know that he earns, this waiter, they earn $105, and that came from $30 in wages, which they get paid once, and then 15% of the tips, in this case, is going to be multiplication. And this step here was impossible to do because if we didn't choose the letter B, if I didn't do that, then you'd be like working backwards in some other way. And I think this is a bit more straightforward. Again, we're going to undo the addition first by subtracting 30 from both sides, and then we're going to divide both sides by 0.15. Grab a calculator, you get $500. Wow, the customer ordered $500 worth of food. Have you ever done that? I don't think I've ever done that. If you have, I want to know about it because that sounds like a story. All right, so let's go on down to here. We've got this massive equation with lots of parentheses and operations and multiplication. I think what I'm going to do first is I'm going to just distribute and get rid of all the parentheses. That sounds like a good first step. So then 3 times 5x is 15x. 3 times 8 is 24, and bring down the subtraction. Bring down the equal sign. Negative 2 times negative x is positive 2x. Negative 2 times 7 is minus 14. Negative 2 times minus 12x. Oh. I thought I made a mistake, but I didn't. I correctly distributed the negative 2 to these two terms, and you don't have to distribute the negative 2 to the 12x because that's outside of the parentheses. Silly Berg. All right, here we go. Let's see if this works. Okay, so I think what I'm going to do here is there's a whole bunch of terms. I'm going to, 1, 2, 3, 4, 5 different terms on both sides. I'm going to multiply all the terms on both sides by -1 because I see a whole bunch of subtraction. And honestly, I think if I multiply everything by -1, all the terms on both sides by -1, it'll just get a lot easier. Check this out. When you multiply the 15x, you get -15x. Multiply -24, you get +24, equals 2x becomes -2x, fine. And then -14 turns into +14, -12x turns into +12x. And now I think this equation is going to be a lot easier to solve, especially from a addition, subtraction, plus minus perspective, because what I'm going to do next is I'm going to combine these two terms together. I see the -2x and the +12x. -2 plus 12, same signs. Nope, add and keep. They are different signs. Subtract. So I'm going to be subtracting the 12 minus 2 to get 10, and keep the sign of the bigger number, because then you'll be exact. This bigger number is 12, so I'm going to keep the sign of the 12. All right. I think what I'm going to do next is add 15x to both sides, because honestly, things get a lot easier when there's only one instance of the variable x here. I see x over here, x over here. Let's add 15x to both sides. And now there's no negatives at all. I'm going to subtract 14, and then I'm going to divide by 25. And when I do that, I get 10x is equal to 10 over 25, which simplifies. You can divide both 10 and 25 by the greatest common factor, which is 5. Dividing them both by 5, you get 2 over 5. Awesome. Here's, oh my gosh, 1/5, 1/8 in an equation? You got to be kidding me. Wow, good night. Well, here's the big tip. Clear the fractions. I mean, obviously, the hardest thing about this equation is the fact that there are fractions, so let's get rid of them. The way you do that is you got to figure out, what is the least common multiple? What's the smallest number that they both multiply up to? 5 multiplies up to lots of numbers like 5, 10, 15, 20. 8 multiplies up to 16 and 24 and 32. What do they both multiply up to? The smallest number the least common multiple is 40. So I'm going to multiply all the terms on both sides by 40. 2 times 40, that's not too bad. This times 40 and this times 40. Well, we have to do some side work, and I'll show you what it looks like. Side work is basically, you're going to take that 40 and you're going to multiply it by 1/5. When you go multiply that across, that's 40 over 5, which simplifies down to 8. So, and you have to do it again here, and then you can also multiply 2 times 40 on the side to get 80. What I'm trying to say is, once you multiply this and this and this by the least common multiple, all of a sudden, there are no fractions. No fractions, no problem. So we can see we're going to get 8d plus 5d, add them up, you get 13d is equal to 80. Dividing both sides by 13, you get your answer. And like I've said before, you don't need to change that into anything else. Let's just report the improper fraction like this. In algebra, honestly, that's often the best way to go. All right, 2/5, 1/6, 3/10, 1/3. Dang, that's a lot of fractions. What is the least common multiple of all those denominators? Like 5, 6, 10, 3. What's the lowest number that they all multiply up to? It's 30. So what you can do is take 1, 2, 3, 4, all 4 of these terms and multiply them all by 30. The first one looks like this: 30 times 2/5. Well, you can multiply across to get 60 over 5, or you can even simplify this. 30 and 5 cancel out and you're left with a 6. In any case, you get 12. You have to do that 4 times total. I'm not going to do all 4 here because I showed you once, and I would have to do it 3 more times. But the point is, this 12, the 2/5 k times 30 is 12k. 1/6 times 30 is 5. 3/10 times 30 is 9k. 1/3 times 30 is 10. No fractions? Wow, no sweat. Here we go. I think what I'm going to do is subtract 9k from both sides, because that just gets variables over to one side. And then I'm going to undo the addition subtraction to get 5. And I'm going to divide both sides by 3 to get the answer. Boom. All right, so here we cleared the negatives. Here we cleared the fractions. Here, I'm going to clear the decimal. It's just going to look a lot easier to do if I multiply everything by 10. The reason I'm doing 10 is because there's one one digit in the decimal, like it's 0.4, 0.6, 0.3, 0.2. If you multiply them all by 10, all of a sudden things get a lot more breathable. So we got 4k minus 6 equals 13k plus 12. All right, variables on both sides. I think what I want to do is subtract 4k from both sides. 4k, notice this minus 6 turns into a negative 6 here because if we were to change this to 4k plus negative 6, then you would see it a lot easier. So I'm going to subtract 4k from both sides, and 13 minus 4 is 9k. I got to undo the addition, so I'm going to subtract both sides by 12, and then I'll undo the multiplication division by dividing both sides by 9. And you get k is equal to, well, why don't you tell me what k is equal to? And before I end this, I do want to say that I was, where was I born? I was born right here in Philadelphia. I haven't lived here my whole life. I've moved all around, but I came back home, and here I am, and happy to be teaching you in Philadelphia too. Tell me where you were born when you come into class, and thanks for paying attention. I'll see you in class. Just kidding. There's a backside. Let me show you what this means. Let's solve this equation right here. X equals x plus 1. Well, I think I'm going to subtract both sides, x from both sides, and if I do that, I get 0 equals 1, which is a false statement. 0 does not equal 1. And it's even weirder when you think about it. This equation basically means what number is equal to that same number plus 1. There's no number that actually satisfies that. It's impossible to solve this equation. There's no solution. This is what we're going to say, or this is what we're going to report when no number makes a true equation. We're just going to say there's no solution. You can't solve that, so don't make me. Let's try this one over here. 2x is equal to x plus x. Well, I see x plus x. I can simplify that to 2x, which is a true statement. And, like, that's strange. 2x equals 2x. All real numbers satisfy that. You're looking at the original. I'm thinking of a number, and 2 times that number is going to be equal to the same thing as the number plus itself. Well, every number does that. So we could say all real numbers when every number makes a true equation. It's just really weird when that kind of stuff happens. Let's try this one over here. Okay, so I think what I need to do is distribute, yay, and then I'm going to subtract 2x from both sides. And then I get negative 6 is equal to 8, which is a false statement. If negative 6 doesn't equal to 8. Turns out there's absolutely no number that you can put into the original equation that makes it work. So we say no solution. No number makes a true equation. No value of x could possibly make this original work. Let's see the top one here. I'm going to distribute, and then, whoa, it's starting to look a little identical. I subtract 3x from both sides, and you get 12 equals 12, which is a true statement. Basically, any number you put in here for x is going to make a true equation. So then we can say it's all real numbers. What is the solution? Every number is a solution. Let's solve for x. Here, then find the length of each side of the rectangle. It's given that the perimeter here is 46. So perimeter is this side, the length of this side, plus the width, plus the length, plus the width. And because it's a rectangle, I can just kind of recopy these things over here. It's the same. And so if I know the perimeter is equal to 46, then all these things added up is going to equal to 46. There's 4 sides represented, length and a length and a width and a width. The parentheses don't really make any mathematical difference. I'm just kind of like trying to group them together so you can see it better. But basically, you can add up all of the like terms. The 2x, 2x, x, x, it becomes 6x. And then 3 plus 3 plus 2 plus 2, that's going to be 10. All right, so let's undo the addition to get 6x on that side, and then divide both sides by 6, and you get x equals 6. Yay, we're done! No, we're not done. We still have to find the length of each side of the rectangle. That's okay, no big deal. We can see here that if x is equal to 6, then the length is going to be 2 times 6 plus 3. That's the length. And the width is going to be 6 plus 2. Now we know what x is. So, boom. There it is. Now we're done. Take care. Thanks for taking good notes, and I'll see you in class. Bergman out.